circuit So this is your battery providing 50 volts of potential difference constant, and this is a resistor of 10 ohms, another resistor 15 ohms, this one is 12 ohms, and this is again 15 ohms. And this is a capacitor of 10 microfarad, and this one is 5 microfarad capacitor, and this is the switch. Yes. Okay, so they have this circuit, and the questions with this circuit is, suppose this is the current flowing through the battery. Okay. What is this current? The first question. When you close the switch. When you close the switch, at the moment you close the switch, what is the current that flows through the battery? Of course, this current will change over time. Because you have capacitors in the circuit. So whenever you have capacitors in the circuit, most generally the currents will change over time. But the thing is, the question is interested in, as soon as you close the switch at the moment, that means the initial value of the current. That's why I use I0. 0 means at time t is equal to 0. So next, what is this current? If you wait for long enough time, that means at time t is equal to infinity. So we denote this current, the same current, but at time t is equal to infinity, or if you wait for long enough time, what is the current? And last, again, if you wait for long enough time after you close the switch, what will be the charges on 10 microfarad and 5 microfarad capacitors? So the final charges of these capacitors after you close the switch, of course initially you start with 0 charge on the capacitors, and you close the switch wait for long enough time, so that there will be no any more currents through the capacitors. In that case, what will be the charges on each of them? So, remember we had this rule for the branches of the circuit which has capacitors. When, as soon as you close the switch of the circuit, and when you wait for long enough time after you close the switch. So when you close the switch, what happens in the circuit is this current will start flowing over the capacitor and the resistor, and we have one more resistor in between again here. But when you close the switch, the moment that the current will flow through the branch of the capacitor as if there is no any circuit elements and as if it is a short circuit. So I am telling you that at the time when you close the switch, the circuit will look like this one. Forget about the values of capacitors. So this is the picture of the circuit at time t is equal to 0 when you close the switch. Well, of course, there are capacitors, but your circuit will behave like as if there are no capacitors, but they are short-circuited on these branches. So with this picture now, you can easily find the current on the main branch. Because the connection of these three resistors are well defined, you can tell that these three resistors are connected parallelly. Okay? Because this point and this point is the same in terms of the potential because they are just connected by a wire. And as if you have, you see, you can transform this picture like this. The main branch is coming, so like you have one resistor in the middle, one top and one bottom, and they are again united at one junction, and this is 15, this is 12, and this is 15. So this is equivalent to this picture. That means your three resistors are connected parallelly. Okay, so the rest is easy because when you have well-defined connections between your resistors, it is easy to find the equivalent resistor. And also, once you find the equivalent resistor, you can find the main branch current by just using the Ohm's law. So the equivalent resistor of these three are the inverse of these three equivalent resistors is just inverse of 15 ohms plus inverse of 12 and plus inverse of 15. But this is the equivalent resistor of only these three resistors. You also have one more resistor which is on the main branch through the battery. So this is, I already calculated, this was 4.62 ohms, but this is, let's call this prime. This is not the equivalent resistors of all circuit because you have one more resistor in here. So the equivalent resistor of the circuit is just this value of the resistors plus 10 ohms because this connection and these are series. So you add just 10 plus 4.62 makes 14.62 ohms. So as soon as you close the switch, the moment when time t is equal to 0, this is what you get. This is the equivalent resistance of the circuit. So the next thing is just find the main branch current by using the Ohm's law. I0 is 50 volts divided by this equivalent resistor of 14.62. This is in terms of volts and this is in terms of ohm. So you got the current 3.42 amperes. Okay. So that's it. This is the first part. And this is how we calculate the first part. Well, again, turn back to our initial original circuit, which has 10 microfarad capacitor in here and 5 microfarad capacitor in here. So the next question is, what is, again, the same main branch current through the battery after you close the switch and wait for long enough time? So when time t is equal to infinite, what is the current? Again, what was the rule that whenever you have a circuit which has capacitors in some branch, if you wait for long enough time, that means these capacitors will get their maximum charge. When a capacitor gets its maximum charge, there will be no current flowing through this capacitor anymore. that means that branch will act like an open circuit. So that means your capacitors are just removed and you have these open ends. Okay? You have just these open ends. Well, the rest is again to find first the equivalent resistance of this circuit, which has this connection. First you come through 15 ohms, and you come through 12 ohms, and you come again the 15 ohms, and continue. But these all the resistors are on the main branch now, so they are serially connected. They are serially connected with this one also. So the first thing is, in the second part, part B, the equivalent resistance of the circuit, since they are all serially connected, 10 plus 15 plus 12 plus 15 makes 13, 22 makes 52. 52 ohms, right? So 52 ohms of resistor connected to 50 volts battery, that means your current will be 50 volts divided by this 52 ohms will give you 0.96 amperes of current. All right, so that's it. It's easy, piece of cake. And what this current is, after you close the switch and wait for long enough time. Well, when you wait for long enough time, of course, these will be the maximum charges of. When you wait for long enough time, since I said that these capacitors are fully charged, remember, you have capacitors in here, and these capacitors are fully charged. 10 microfarad and 5 microfarad. But we wonder what this charges on each of these capacitors, right? So if you want to find a charge on a capacitor, just use this formula. Q is equal to C times V, right? Q is equal to C times V. C is just constants. They don't change over time. But V, the potential difference across the terminals of these capacitors, change over time because the current changes over time. But we are interested in the potential difference between the terminals of each capacitors as time goes to infinity, when the main branch current has this value of current. We just found 0.96 amperes. So if you wait for a long enough time when these capacitors are fully charged, the current flows here, 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 over here, and goes. Continue. Then no more current flows over this, and we know already what this current is, 0.96. When you know what the current is, you can calculate always the potential change when you cross all these resistors. When you cross first the 15 ohm resistor, the potential change will be 15 ohm times 0.96, which is the current. Again, continue and flow over the 12 ohm resistor. Your potential again will change 12 times 0.96 amperes and reach here. So this change, for going from here over these two resistors to here, this change can be calculated. It's nothing but the potential change from here to here is just the current flowing through these resistors multiplied by the resistors itself, because they are serially connected. Multiplied by the current flowing through these resistors is the potential difference between the 10 microfarad capacitor. So let's write it. All right. So C, the charge on the 10 microfarad capacitor is 10 microfarad times the potential difference, but the potential difference can be written as this current times the sum of these two resistors, because they are serially connected. Says, okay, just the battery is running out. Change them. So you should be able to hear me now. Says, okay, I was just calculating the charge on the 10 microfarad capacitor. So the formula goes like this. You multiply with these three quantities, the capacitor, the current through the 15 and 12 of resistors, and current itself. But the current itself is already calculated in the previous section, 0.96. So just do that. What you find, okay, at the end is, you can do it yourself also, but what I found is 260 microcoulomb of charge. So this is the charge on the 10 microfarad capacitor. What about the other one? The charge over 5 microfarad capacitor. So just look at the picture. Look at our circuit. The potential difference across the terminals of this is the current flowing from this point to this point multiplied by the equivalent resistance on this branch. But since at time t is infinity, the current flows in this direction, these two resistors are serially connected, and the sum of these two resistors multiplied by the current flowing through them will be the potential difference across the 5 microfarad capacitor. Let's write it down. 5 microfarad, C, multiplied by I infinity, because it's already calculated in there. And first you cross the 15 ohm resistor plus, and next the 12 ohm resistor. You first go through the 12 ohm and then 15 ohm, so you add them all. And you do this calculation, you get what you find is, of course, it will be half of this, since the same